a few practical details, and then we'll get to the fun stuff in a minute. So welcome everybody to another Google Developer event hosted by us in Orbit Lab. So in the beginning of lockdown back in April, we had a Google Developer meetup with Filip about web components. And back then he told us about this project he was working on. And this project is actually what we're going to be talking about today. So before we begin, I just have a few quick things to go through. So first of all, I want to make you all aware that we're recording this talk and that we'll make the recording available on our channels. However, of course, we encourage all of you to stay put because it's always more fun to be here live. So the program today is live coding, as you probably all know. And at the end, we have a Q&A session. So this is the organizing team, myself. I'm the community manager here in Orbit Lab, and my name is Lille. And we have Kasper, the man with the many titles. You will get to meet him. You're welcome to ask questions in the chat during the live coding. I'll try to keep an eye on it. And we also have a Q&A session in the end. And just a quick advertising spot for some of the other upcoming events we have this November. All of the events are free to attend. You have to register, of course. And you can find details on our website and on Facebook. And I'll post the links to the individual events in the comments. To those of you who don't know Orbit Lab, we're a tech hub and a community located at Aarhus University. And we encourage you to follow us on our social channels and, of course, to keep up to speed with what's pretty much all from me. So now I'll hand you over to Kasper. Over to you, Kasper.
Thank you, Lille, for that introduction. My name is Kasper. I'm one of the organizers of Google Developer Group Aarhus, and have been doing that for a while. And one of the my favorite parts of being in these communities is that we get to have really smart people drop in and share some of their knowledge. And now this is the second time this year that we have Filip. He's also our local Google developer expert on web technologies. That means that he knows a lot of stuff about it, so much that he decided to designate him an international expert in it. I think Filip will talk a bit more. He also transitioned to a new position recently. So a lot of exciting stuff. Regarding the community, hopefully most of you are already members of the GDG, but if not, please sign up and don't miss out on any future events. And of course, in these COVID days, things are very strange and different, so we're not having our physical meetups like we used to have. So, but it turns out it can still work out with these online events, and we get great speakers from all over the world coming in. And if you are sitting there and thinking, group, that sounds exciting, how can I be part of that? Then don't be shy to reach out. We're always looking for new people who wants to be part of the community and wants to contribute, helping to set up talks. Maybe you have something you've been working on yourself that you want to come and talk about. That will be awesome. We're actually missing having some more like local community stories, like what are you guys working on? Like what technologies are you on? And just showing, maybe it's your private projects or stuff from works that you can share. So hopefully in the new year, we will have more of these a bit less like full talk events, but more like show and tell kind of sessions. So shoot me an email or Lille if you're interested in joining Google Developer Group Aarhus. And then without wasting any more of your precious time, I will hand it over to Filip, who will introduce himself. Over to you, Filip.
Nice. I was just trying to find the unmute button, as we do in pretty much all meetings these days. Hi, everybody. Well, maybe I should. Yeah, that'll be fine. Do you see my screen? I hope somebody can yell out yes.
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 Excellent. Nice. So it's good to be here again. It's always fun to be part of this local user group here in Aarhus, and even with special guests from all across the world today. We could hear, for those of you joining early, that's very nice. Today, I thought it would be fun to touch on Bluetooth from the web and speak to that a little bit. So we'll go all the way from a complete blank canvas. I'll introduce some of the technologies that we'll use as we go along, and we'll end up with a complete, or like a POC bicycle app that works offline and that can track your heart rate and speed and cadence from another sensor that we'll look at. So that's what we'll do. I think this is probably the first time that I'll do a complete presentation without any slides. So you'll have to bear with me and cross your fingers that the demos will go and everything will work. I tried it out 10 minutes before joining and realized that one of my sensors were out of battery. So that should be covered for now, but that got my nerves up. So that's all good. Bluetooth, to give the briefest of introductions, is a communication protocol. A subset of Bluetooth is available on the web. We call it Web Bluetooth. It connects to Bluetooth low energy devices primarily. And the idea of Bluetooth low energy, which is the newest standard of Bluetooth, is that we want to not focus on speed and all the stuff that we normally talk about, but we want to talk about battery time, because for sensors in IoT or in like for bicycling or whatever you want to do, the battery time is way more important than the speed of the data. On Bluetooth.com, you can find all the specifications. That's just why I put the website out to remind myself to say that. So if you want to, go check that out. But we will just jump right into it. I created a folder called Web, and that's all I've done to prepare. So let's open that. So here is Visual Studio. Let's make an index file. And do I need to make this larger for you to see? Code, probably a little bit.
I was just about to say, yeah, it's at least on my screen, it's very small.
Larger than this, or is this fine?
Yeah, well, you have to zoom in as well. Yeah, that it gets better.
It gets
fine.
You're okay?
Yeah.
If anybody's not okay with this, yell out loud. All right, so this is a blank canvas application. I haven't done anything yet. Let's just start out a web server. So in my terminal, I'll just run npx HTTP server. That's probably the easiest way to get started. And that should start up a server that runs from this particular folder. So now if I go to localhost port 8080, I should see nothing because there's nothing here. But if I do something, we should see it work. Yes. Okay, so we have a running web server. The reason why we need a running web server is that like many of the technologies that we'll touch today, they need to run on an HTTP or HTTPS protocol, and actually most of them actually need to be on HTTPS, so they need a secure connection. But we can do all of that from a local machine, so that's fine. Maybe I should bump this up a little bit as well. All right. Our blank index file needs to contain something, and part of the security model for talking to Bluetooth from the web is that we need to react to a user gesture to get started. So we can't just start searching for devices in the background without anybody wanting us to, or without the user wanting us to. So we'll need to have some kind of user gesture. And the easiest way to do that is to make a button that says, connect my device. And to reach that from JavaScript, we'll give it an ID of something, btn for here. And just to have separation of concerns, I'll actually make a JavaScript file, and that will then reference from a script tag. and now we should be good to go. So in our JavaScript file, we will find our button. And we'll attach an event listener to it. We'll listen for the click, because as I said, we need to have a user gesture to get started. So this should run whenever we click it. Let's just make sure that that works. I'll open up DevTools, and now you should see that when I click it, we get an event log to the console. Maybe I should make that bigger as well. Hope you see it, otherwise yell out loud. All right, so Web Bluetooth is available on the Navigator object, so we do navigator.bluetooth, and here you see that it seems Visual Studio Code doesn't know about Web Bluetooth, and we need to teach it that. So in order to do that, we will add the types. The easiest way to do that is to init a new project, an npm project, without setting anything. So we'll just do --force. And then we'll do npm install add types /web Bluetooth, and we'll save it. And this, if all goes well, gives us a package JSON, a node modules file that contains all the types. And now if you see me writing again, you see that VS Code now knows that there's something called navigator.bluetooth, and it actually knows everything that's on this object. On navigator.bluetooth, the most important thing to know is we have a method called requestDevice. And requestDevice takes an options object. And this object, you can define filters, which is a list of the filters of devices that you want to search for. And we want to search for a device that has a service, which is again a list. Bluetooth are typically have like a long GUID or something representing them, and the most common ones they have like human readable short names. So I'll just refer to them with that name, and you can find all those names and the short names on the Bluetooth.com website if you're looking for something. But we're looking for some device that has a service that's called heart_rate, and this should give us back a Bluetooth device. All of this is asynchronous, of course, because we will calling this method will actually trigger the browser to allow us and to search. And then once the user has selected a device, that's what this method will return. So it's going to return a promise that then fulfills to the device. I can't spell right now, apparently. So let's just log this device to the console to see how it works. I'll save it, turn to my browser, and hopefully now we should start seeing that the sensor I have under my shirt that I just disconnected by accident should find its way to the screen. It does. I will click on it and say start pairing, and now you see here in the log that I got access to a Bluetooth device with a GET and an ID and some name and that kind of stuff. And that's how it's represented in JavaScript. What we really want to do here is actually say this device has a method on it, or has on the GET, which is short for generic attributes, I think. On the GET, it has a method called connect, which then actually connects to the device. So the first thing is find the device. Now we connect to the GET server on the device, and this will give us back a GET server. This GET server has a couple of methods on it, but primarily it has a method called getPrimaryService, and you say that, or you call that with the argument of the name of the service that you want to then connect to, because it might have more than one service available. So we're finding the device, we're connecting to the GET server. From the GET server, we're connecting to, we're getting the primary heart rate service, which is again a promise, and this promise gives us back the service that we're looking for. And this service This is where it is a little bit of a funny dance. But this service then has one method again that's called get characteristics, and characteristics are actually the object or the element that we're looking for, because this is where the events are being triggered on. So we're looking for a characteristic, and the characteristic we're looking for is called heart rate measurement, because that's obviously what the heart rate service is for. And now the dance is more or less complete. So now we get a characteristic, and this characteristic is actually what we want. So let's try and log that to the console and see what this contains. So we'll reload the page, we'll connect to the device. This time it should be hopefully a little bit faster to connect. It does, and after a little bit of async dancing, it gives us back the Bluetooth remote GAT characteristic that we're looking for. And this is exactly what we want. So characteristics. The main thing you want to do on a Bluetooth characteristic, at least when you're looking to read data, is to actually listen for an event whenever the characteristics change. So on the characteristic, we'll add an event listener. So this is very familiar if you're a JavaScript developer, that VS Code knows that there's only one event on this, and it's called characteristic value changed. So that's quite a mouthful. But that's what you listen for. And when this event fires, it means that the heart rate monitor has received a new heart rate measurement, and it's available for us. So if we do this, and it's a regular event callback, this function is going to be called every time the characteristic value has changed. The interesting part is that if I now log this event out, it has a target, and the target has a value, which is actually what we're looking for. But if I do this, nothing's going to happen. So I can do it just to show you that nothing happens. And that's a battery concern as well. So the GAT server, or like the device, it doesn't actually emit this event before you tell it to, because why would it waste cycles on actually emitting events if nobody cares about them? So on the characteristic as well, we will call start notifications, and this should give us what we're actually looking for. So now when I connect my device, we should see that pretty often I will get a data view. This is about once every second, but that's not in the standard, so that could be just a random piece of log. Data views are something not necessarily human readable right out of the bank. So I've actually prepared a little helper, just so you don't have to watch me type this all over. But there's a little heart rate function, heart rate parser function that I'll copy paste in. The implementation of that is not really important. You can actually find this code directly on GitHub from the Bluetooth specification side. So instead of just reading or logging the data view, let's call that function parse heart rate with the value that we just received. We'll store that in a variable. We'll call it HR, whatever. And for now, let's just try and log that to the console. And now we should see, if all goes well, that you can actually start reading my heart rate. And you see my heart rate is 60, around 70, 72, something like that. I think that should be reasonable compared to a little bit of stage jitters, but I think that's fine. It means I'm alive at least. So this is the app. This is like the basics of connecting to a physical device from JavaScript. It's actually not too complicated, and it's, this is like the first step that I wanted to talk on. Again, as Lita said, if you have questions, I can't see the chat as I'm saying that, so write them and Lita can yell them out for you, or you can just start yelling out if you have questions. Otherwise, I'll move on.
we're on it. We'll read any questions.
Excellent.
So Philip, I just have a quick one myself. Is there
Yes.
any way that you can specify the sample rate, or like, is there any ways to call into the Bluetooth, the GET server? And
some devices have a way to do that, I think, where you can actually set a frequency or something like that. But I'm not sure how much of that is actually required. So it might not be for all devices. So that's kind of a political answer of saying I'm not sure that will work everywhere. But there are ways, just as you can listen for stuff, you can read stuff synchronously from the device, and you can write back stuff to the device. So yeah, there might be devices that would support that you could write back a frequency.
cool.
Great. So I'll hurry up and turn that off so you don't see my heart rate moving on all the time. Yeah, so as I said, we will connect to 2 different sensors today. The other sensor, we'll just get back to that a little bit later. But the point is that most of the dancing here that we saw on the top is the same. The difference is the heart rate, or like the service name, is different, and the characteristic that we're looking for is different. The event name that we're listening for will still be the same, and of course the data format of whatever is returned is different as well. So this means one of the first things, or one of the next things we'll do, is actually turn this into a generic component that we can then reuse. But before we do that, I thought it would be fun to also play along with web audio. So web audio is one of those parts of the web specification that I haven't really played along with so much. So it was actually kind of fun to play with this. So I think I'll just dive right in. So the point is that I wanna make a little beep that can beep along with my heart. So if my heart rate is at 60, the beeper should be at 60, and every time the heart rate updates, the beep frequency should update as well. So that's what we want to do. The first thing we need to do is actually, write the code that plays the beep. I wonder how that beep's gonna come out on Teams though, but we'll have to find out. But the way we do it is we start out by creating a new context. So we'll do const audio context equals new audio context, and then we'll create a gain node. The reason we do that is that we want to be able to turn the volume of the beep up and down, and we do that on the audio context by saying create gain. And then we connect the two, so we say gain node dot connect, and we connect it to audio context dot destination. So this means that whenever the audio context has to play something, it needs to go through the gain node. Then on the gain node itself, we can say gain node dot gain dot set value at time, and then we can set the value to something to not play it too loud. We'll just set it to 0.5, which is 50% of the maximum volume, and we'll do that on the audio context. So it says at time, so we need a timestamp for this, and on the audio context there is a current time, which is now. So that's how we set it to do it right now. Then we'll actually make a function that we can call, that's the beep. So anytime this function is called, we want to play a beep. And the way we do this is to create an oscillator. That is one of the hardest words I know to say in English, so if I don't say it right, bear with me. So on the audio context, I'll call create oscillator. And on that OSC value that I just created, I will connect that to the gain node. Then we'll set the frequency of the oscillator, and we'll set it to 880, which should be a straight A. And then we'll call oscillator.start, which should start playing a sound. So if all goes well, I hear a sound. Do you hear the sound on Teams?
No, sorry.
No. Let's see what we can do about that. That would make it a lot more fun.
It's probably in your headphones, right?
It is in my headphones. So question is if I can do something like play sound. And then, do you hear the beep now?
Yep.
It's nice, right?
Super nice.
Maybe in here I can do. Yes, excellent. So now you should be able to hear the beep. So obviously we don't want the sound to go on forever. Let's actually stop it again, and stop also takes a time. So we'll do audio context.current time, and then we'll just add, you know, 1/10 of a second or something like that. So this should mean that now you should hear a beep. Nope.
Yep.
We hear a long beep. We should hear a short beep now. Yeah. Do you hear the beep?
Yep.
Nice. Excellent. So I should have prepared for that, but that's, I'm sorry about that. So what we really wanted to do is actually make the beep along with my heart rate, right? So let's just make a variable here that we can change, and then we'll just update that HR value anytime the heart rate monitor actually gives us a new beep. And if I am not much wrong, I think, what did we call that event? Dot heart rate. I think heart rate. Something like that. We'll see. We'll see how if that works out. All right. So what we want to do is then have some kind of loop. So this is almost like game programming, right? Where we do a ticker, and then anytime the tick runs, we will check to see if the time has passed since the last tick, more than the amount of time, milliseconds, divided by the heart rate, so that we should play a beep. And if it is, then we should update some kind of time to start checking based on that time. All right, so that was a little bit of a weird explanation. But let's make a function. We'll start out by calling it once. Anytime it's done, it's going to request a new animation frame, and it calls itself again. So this should just be a function that calls itself over and over again. Then we'll make a variable that we call last time. We will initiate that to right now. JavaScript is fun like that. New date.getTime. We will make a variable then inside of the tick that gets the current now. Same thing. And then we'll simply, or not simply, but then we will subtract one from the other and see if that is greater to 1,000 divided by HR divided by 60, because the HR is 60 times or per, so it's beats per minute. And of course the 1,000 is because we get the get time is in milliseconds. So if this is true, then we will update the last time to be equal to now, and we will play the beep. And, well, maybe not start the ticker here. Let's start it in here when we actually have a value. All right. So connect the device. It's going to take a little bit to wake up again because it has been off. So that's how Bluetooth supports, saves energy. And now you should hear a beep along with my heart rate. And I think we'll just keep that on for the rest of the talk.
Can you get up and do some jumping so we can verify?
I will do no jumping jacks. Nice try though. Of course, this is not that much of like a real app. Like we want to turn this into something, and I think the intro or like the brief said something about web components and PWAs and all that stuff. And of course, that's fun, and I want to do something like that. So I prepared a little starter here, And this is just so you don't have to watch me set up Webpack and TypeScript and all that jazz. If you really want me to, I probably could, but this is also something that I don't do every time. So I created a starter pack. I'm just showing you the package.json to show you what I did. I added lit element as a dependency. Lit element, I'll get back to that, but that's like a tiny little micro library that Google has built for making it very nice and convenient to do web components. Deco is just a simple set of helpers that makes it where you can decorate stuff in JavaScript, and it makes it a little bit nicer to work with. And then I added the same types for Bluetooth as you saw me add just before. The rest of this is just Webpack magic for TypeScript, and then there's one job, which is during development time, we run the Webpack dev server, and for build, we run a Webpack with a config name of prod, which should bundle everything up and do all that jazz. So nothing too crazy here. And of course, we need to then actually boot from that folder. So we'll open up a new terminal here. npm start. Open up a new browser, and now we should be back to not seeing anything, which is perfect. Yes. So the warning you're seeing is because at a later time we'll be adding a service worker file, so don't worry about that for now. So the main TS file is the TypeScript entry point of the build. So here we're going to reference everything that we actually do in TypeScript. So if you don't know, TypeScript is like a superset of JavaScript. So anything that's valid JavaScript is valid in TypeScript, but TypeScript then adds some nice stuff on top that then compiles to JavaScript that actually runs in the browser, but it gives us type safety and something like that in JavaScript. So that's kind of nice. And lit element, the framework that we're going to look at, or the library that we're going to use, is built to support TypeScript, so it actually works really well with TypeScript. It's not a requirement, so you can use it without, but it certainly is really nice. So I created a folder called helpers, which is where the heart rate parser function lives, and there's a similar parser for parsing speed and cadence from the other sensor. That's all there is in helpers. And then I pre-built a couple of elements, and we'll get back to them when we start using them. But inside elements, let's actually create a new file. We'll call it my app element, and it's a TS file because it's TypeScript. And to get started, we'll actually, in main, just import that file. And this should mean that we are now going. So to build a component in lit element is simply a JavaScript class. Then you add some stuff to it, so it's no longer just a JavaScript class, but it is, and it's bare bones, it's a JavaScript class. Components are pretty much the same across all the frameworks, and that's why a group in Google and in the standards body that came up with web components a million years ago, because it was kind of a nice thing to have as a primitive in the browser that the frameworks could then build on top of. And lit element is an example of doing just that. So our class will just export a class from JavaScript. We'll call it my app element, just so it makes sense from the file name. And when we build web components, traditionally we extend the HTML element object, which is like the base class for all elements in the DOM. But here we're actually, instead of extending HTML element, we're going to extend lit element. Lit element is an import. You saw that VS Code automatically imported this from lit element, which is the library that I was just talking about. So lit element then in turns actually extends from HTML element, so we don't have to do that. The way you then make this into a web component is you use a decorator. You decorate it with the custom element decorator, which is also a decorator that we get from lit. And we decorate it with, or we call that with an argument, which is the name of the element that we want to have. So let's call it my app. And now we have a web component defined, which has the tag name of my app and currently does nothing. So in order for it to actually print something to the screen, let's implement a quick render method. The render method should return a special thing from lit element as well, which is the HTML tag. And I've talked about tag template literals many times before. But if you haven't heard me talk about it or haven't heard anybody else talk about it, the idea is that we can define a string in JavaScript with backticks. And when we do that, it's called a template literal. And you can then tag a template literal by putting a function name in front of it. And that actually calls the function for us with the template literal, but it also gives us some nice hooks into the template literal. I'll get back to how it works maybe a little bit later. But for now, just know that we import the tag as well from lit element, and then you write these funny backticks, and we're good to write our template in here. So let's just put an H1 in. We'll say hi GDG Aarhus. We'll close up the H1 again. And now, if we go to our index file and actually reference the my app element, we should see that it automatically refreshes in the background because the Webpack stuff does that for us, and we actually have our tiny little app running now. So the basics of lit element is that we extend from lit, as I said, from lit element. We decorate our class as a custom element. We have a render function that returns a tag template literal that's tagged with the HTML tag function. And that's the basics of lit element. So in frameworks like Angular or in Vue and React, the typical story is that you pass data into components, into child components, and then child components typically have some kind of way to communicate back. So in Angular and in Vue, it's typically focused around events. In React, you typically pass down a callback function that's then called, but it's more or less the same flow.
Sorry to interrupt, Philip.
Sure.
We have a question from the audience.
Yes.
Was template literally? Okay, Abdul, do you want to grab the microphone?
Yeah, why not? So you mentioned template literal.
Yes.
Thing on line 10.
Yes.
Was that as lit element specific functionality?
So the template literals, so just writing a string with backticks is a standard story. So that's just JavaScript today. You can do multi-line strings with backticks. Then tagging a template. So the idea of tagging a template is also a standard thing. So you can have there are lots of different tagging frameworks out there that builds on top of tagging. But the HTML function or the tag that we actually use here comes from lit element. So this specific tag is implemented and imported from lit element, but the idea of tagging and having template literals is not lit element specific.
Okay, awesome. So if I just posted, if I wrote button there instead, it would just create a button with some text in it.
Yeah, if you in here you could write a button and that would be fine.
Oh, I mean where you put HTML element.
No, so okay, so let's dive into that a little bit. So the idea is that you can make a template literal, and any template literal can have expressions inside of it. And expressions inside of templates are made with a dollar sign and curly brackets. So anything you then put in here is an expression. So this could be a string, hello. This could be like a ternary that says some condition is if it's met, it's this, and if it's not met, it's that other string. This could be like an array that is mapped, or like any expression from JavaScript can go in here. It can just be a value. So if we have, let's say we have a member on this class that's called name, that is GDG Aarhus, then we could actually use the template interpolation and actually put in this .name right here. So we can have any expression actually inside of a template literal. So this is nothing lit specific. This is just how JavaScript works. And then the idea of the tag here, so the HTML function, is that when you tag a template literal, it actually calls this function. This is just a regular JavaScript function, and it's called with the template or the string that comes after it, but the string is cut in parts. So the first part would be this until the whole, and then the next part would be whatever is after the like the whole or the expression that we put in here. So maybe we have multiple of these, and that would mean that then here we have a div or whatever. That would mean that the HTML function would now be called first with this line, then with this, then with all of the rest of it. And then as the second argument to the HTML function, it's going to be called with all of these expressions that are actually then put in the template. So what lit element does with this is then actually be clever around doing dirty checking and figuring out what values has changed since last time and what nodes do we already have and how do we keep that up to date. And that's where like lit element implements something kind of like React's virtual DOM, or kind of like Angular's templating system, or like Ember's Mustache templating language or something like that. It's pretty similar to that. This is just like a browser or a JavaScript standard way of having this functionality. So instead of doing it, I think in Mustache, this was done with a regular expression that just looked for this and this, but now it's actually part of the standard. So lit element comes with two tagging functions. One of is HTML, which supports anything that's HTML in here, and the other one is SVG, which of course supports anything that's SVG. So if you want to use an SVG in a folder or in a template like this, you can just put the SVG tag instead of the HTML tag, and that way it will support
Filip?
that. Yes.
Sorry to interrupt again. We have another question. Nils, I think it's best if you just grab hold of the microphone.
Well, I was just answering the question, I guess. It wasn't the question itself for Abdul Rahman.
All right.
Sorry, I didn't read to the end. I can see there's no question mark.
Okay.
Carry on.
All right. I'll try to carry on. Yeah. So let's just go back. We should see that it actually now still says GDG Aarhus because I was referencing something in my template, and that automatically just goes through. So the question is, when you have a framework like this or a micro library like this, is when do we update this? It's like, when do we re-render the template? So let's say that for the example, let's do a constructor that calls super, of course, and inside of the constructor, let's set a timeout that actually changes the name. So let's change the name to something else after 1 second. And now we should see that even after 1 second, it doesn't change, because lit element doesn't know which properties to look for changes in. And this is like, if you're used to doing React, this should be very familiar to you, because of course in React you would either have Redux do it, or you would call set state on the component, and that's how you tell it to re-render. In Vue you can kind of have either or as well. For Vue or for lit element here, on this there's actually a method that's called request update, and if you call that method, it's then gonna actually update the view after you call it. But this is typically not really what you want, right? You wanna have some kind of magic going on, so that you don't need to explicitly call it every time you want it to change. So in order to make that a little bit easier, there's another decorator. So on the name property that we have here, we will decorate that with a decorator that's called property, which is also a decorator that we import from lit element. We decorate it like this, And that means that now lit element is actually, what it's doing under the hood is actually just implement a setter and a getter for this value. So anytime it's set, it calls request update for you. So there's no secret sauce in it. It's pretty simple for a framework concern, but it is something that a framework should do for you, right? So if you decorate a property with the property decorator, you will have the magic that anytime the setter is called, so anytime it actually has a new value, it's gonna re-render for you. So that was a long story, but this is how lit element works. So the only other part we talked about was, so this is when this is like if you want to then pass a property onto a child component, we can just have any component in here. We can pass to a div if we wanted to, because that's a regular JavaScript, regular HTML component or element, and we can just pass to that like the ID. We can set it like this. If we set it like this, it's actually gonna set the attribute on the element. But if we want to pass something that's a property, we can put a dot in front of the name, and that actually means that now we can set a property directly on the div. And I know if you haven't played around with this, this might be something that's a little bit weird to understand, because in JavaScript or in the DOM, attributes and properties are very closely linked, but they're not the same. And so the main difference is properties, attributes can only hold string values, and attributes are actually the stuff that you write in your HTML that the parser then turns into properties. So that means that most attributes are then being ported over to a property when it's actually loaded in the browser. But properties are a little worse for performance reasons, because you can do styling based on attributes and stuff. So anytime an attribute is changed, it's gonna redo all your style work for you. So and typically also because you can store anything in a property, you can store like an array or an object or anything like more complex than a string. So typically, what my suggestion would be, use properties for everything until you really need it to be an attribute, and then you can turn it into an attribute. And as I said, when you want to set a property on something with lit element, you prepend the name of the, like you write it out as if it was an attribute on HTML. On the HTML element yourself, and then you put a dot in front of it, which means bind this as a property. So the only other syntax that we need to learn for lit element templates today is that if we want to listen for an event, we put an @ sign in front of the attribute name, and then we write out the event name. So let's say this was a button instead. So if you want to actually listen for button clicks, we'll just do @click and then reference a function, just like up here we're referencing a name, like a member or a property. Now we'll just reference a function. So let's make an onClick function here, and then we will call this whenever this is clicked. So now when the click event fires, it's going to call the onClick event on or onClick function on our MyApp element. So this is more or less how we do everything from passing properties down to child elements to listening for whatever they give us back. And that's more or less how we do most applications today, whatever framework you do. So I thought it would be fun to actually try and use some of the Bluetooth stuff that we've built, and for that I prepared a little function as well. So I prepared an element that is called connect sensor. So now I'm just duplicating it in to save time. Google in Finder. And what connect sensor do is take a property that is a configuration object, and then this configuration object will contain like information about what is the service that we want to connect to. So if you see from the beginning of the code that I wrote in the start, this is more or less the same code, right? Except for this is not hard-coded to be the heart rate service anymore. It comes from a configuration setting, and the same down here, and the characteristic name as well. And then the last thing this connect sensor element actually does is support that if you pass in a parser function to the configuration object, it'll actually run that parser function on your on the data before it returns it. And the way it returns it is that it dispatches a new event. So this is how we do, like when you want to fire an event to your parent to catch, we just use the native DOM methods for dispatching events. So we'll call this.dispatch event with a new custom event, and we call the custom event value, and then we can pass whatever we want along with it. The only contract of custom event is that whatever we pass to it, we pass on a property that's called detail. We can pass anything to that. It could be a complex value or a simple value, that's fine. The template of the connect sensor element is pretty straightforward. So if it's connected, it shows whatever is inside of itself. So it shows the slot. So this is a web component specific thing. We won't go into that too much right now. And if it's not connected, it shows you a button. It shows you a button that gives you the opportunity to actually connect to it. So this is just a little bit of wiring around all the stuff that we talked about. Already. So what we want to do here now is then actually use that connect sensor element. In order to use it, let's start by importing it. So we'll import connect sensor element, and then it's going to register itself so we can use it in the template here. So in the template, we will then do connect sensor. I'll close it off again. And to connect sensor, as we said, we want to pass in a configuration. And the configuration, as I said, is a property. So we'll do dot configuration. And then we will do the whole where we actually fill in the configuration. The configuration itself is an object, so we'll do another set of curly brackets and write out the configuration that we want. So to get started with the heart rate stuff, let's listen for the heart rate service. The characteristic that we need here is called heart rate measurement. The name is heart rate. This is just so the button says the right thing on it, the connect button. And the parser, I actually have that available as well, so we can just import that parse heart rate. You see that it automatically imports it for me from my helpers folder. This is more or less what we need to have the button showing that connects. Then what we want to do after that is actually listen for the value event. So we said whenever we get a new event, we'll listen for that it's going to be called value. And let's make a function that we call on HR update or something like that. Let's implement that function. That's going to be called with the heart rate event or the heart rate value. And then we should probably store that somewhere. So let's make a heart rate that's just defaulted to 60 or something like that. And then whenever this is right, let's do HR event dot detail, because that's where we save it on. And it gives us back that object that also tells it if it's connected to my skin and stuff. And what we're looking for here is, as we did the last time, is called heart rate. So this should mean that when we connect to the sensor, we use the generic connect sensor element that takes a configuration here that listens for the heart rate service with the heart rate measurement characteristics. It runs it through the parse heart rate function. And anytime there's a new value, it's got to emit the value event that we then pass on to the on HR update function that then updates the local HR value. So if we want to decorate this with the property decorator like we did before, and then let's actually show the value. So let's show it in here. We'll make a hole. We'll do this.hr. And this should mean that if all goes well and the heart rate monitor wakes up again, we should see now actually see the number being reflected. See, my heart rate has risen a little bit, but I think we're good to go. So this is kind of nice, but of course, so far we haven't really done anything except for what we already had. But the cool thing about this is that if we want to actually learn something more, I brought another sensor. So if you look at the camera, you can see that I'm holding up a sensor that would go on the bike, and then there's a magnet that would go on the wheel. So this means that anytime the wheel spins around, it's gonna pass right through this, and that actually gives us some information about. There's a sensor in one of the ends, which is on the wheel, and then there's a magnet on the wheel, and another magnet on the pedals, so it can give us a cadence of how fast you're moving your legs, and then it's going to give us more or less a cadence of how fast the wheel is spinning around. So we want to actually show those two pieces of data as well. And this is where the generic connect sensor element really shines, right? Because now let's actually connect to a service here that's called cycling speed. I have to spell this right though. Speed and cadence. That's the service name, and the characteristic name is CSC measurement. And this would be, let's say, connect bike. And I actually have another parser for this, which is called parse CSC. And the value event is still the same, but the function, of course, should be something else. So let's do one CSC update. And let's implement that function as well. CSC event. And for now, let's not worry about printing it. Let's just print it to the console so we can see that it actually works. Because now we should have two buttons here. If we say connect bike instead, and I start moving the sensor, like I was a wheel, I was spinning the magnets, you should see that we get events firing down here. And these events actually, on the detail of them, contain information about how many times the cranks has spun around and how much time has passed. And that information, of course, we can then actually turn into information about distance and speed, and that's what we want to do next. Let's just, so we have that value available the same, we'll do this CSC equals CSC event. No. CSC event dot detail. And now instead of just printing out the value here, as you saw before up here, I've actually prepared a couple of helper elements that we will then use. So one is show cadence, one is show distance, and one is show speed. And these are all supposed to be used with the CSC data. So let's start by importing them, just like we did before. Show cadence, show distance, and show speed. And now we can then use them. So in here we'll do show distance. It actually auto-completes for me. It's pretty nice. And all it takes is one property that's called data that takes the CSC value that we got just before. And the tag isn't closed. Thanks. Show speed. And I think that takes the same property here. If you really want to, we can talk about how those are implemented afterwards, but it's just looking at the data and doing some math around how long is a revolution of the wheel, and then taking that into doing some math on that. So that's not really that exciting. All right, and I actually also, just for the heck of it, implemented a beep metronome element that would do the same as we did for the heart rate. So it takes the heart rate and plays a beep along to it. So let's use that as well, beep metronome. And I think it takes a BPM property here. That is the HR. So if all goes well, we should now first connect a heart rate sensor, which should give us an element. And if I click it, that's how I've implemented it, so we don't have to listen to it all the time. It can play. I can click it again to shut up, and I can connect the bike. And now we should see speed and cadence and all that stuff being displayed right here. No, maybe I should write that out a little bit nicer. So we'll do after distance, let's do kilometers and then do a break. And here, let's do kilometers per hour and do a break. And for cadence, we can do RPM, just so it's sure what's actually shown. Yeah, now you should see that I'm traveling at a speed of 16 kilometers. If I move the magnet faster, you should start to see the speed increase and decrease as I go along, and the distance should not stop, but just stay where it is. So that's kind of nice. And if I move it over and flip the magnet on the other side, we should see the RPMs starting to move. So of course, this would come from either the wheel or the actual bike from your feet. So this was more or less all that we had to do to build a bike computer. So the last part of it that I want to talk about is then actually making this bike computer work offline. And the way I implemented that is with a service worker. So I want to create a file here that we call serviceworker.js or sw.js, and the service worker file needs two things. So a service worker is a JavaScript worker, so kind of like a web worker, if you know what that is. But it's different in a couple of ways. So being a worker, it doesn't run on the main thread like the rest of the code. Being a service worker means that it is not directly tied to any specific session. So it's not tied to one window if you have one window open, and it's not even tied to a specific session or any session. So that means even after the window is closed, the service worker actually is still alive on your website. So for performance and battery reason and stuff, that's actually not the fact. So it actually turns it off, and then it can wake it back up for you and stuff. And we have to, that makes it so that the service worker API is very service-based or like event-based. So it wakes up and it does something and it goes back to sleep again, and we have to work with that. So the way we actually use a service worker is we call navigator.serviceworker.register, and we call that with the file like the script URL that we want to listen to. So this was sw.js, and that returns a promise, and the promise actually gives you like the service worker registration. In this case, we're not going to use the registration for anything, so we'll just log to the console and say service worker installed or something like that. But if service worker are also the plumbing behind push notifications on the web, and if you want to work with push notifications, you have to deal with the registration. That's actually how you can ask for permission to receive push messages. But this is how we register our service worker, and now let's save that. And now the rest of the code actually lives in the service worker. So if you're paying along, if you're timing along, 5-10 more minutes, we should be done. So the service worker is very much event based, as I said. It doesn't have access to the window, so there's no window or no this. So instead we call methods on self, which is like a reference to the service worker itself. So we call self.add event listener, and then we listen for a special event that's called install. And the install event actually fires with an event, and that fires when the service worker is first installed. So until there's a new version of the service worker, it's not going to be called again. It's only going to be called once for a service worker. As I said, in order to know when it can kill the service worker again to save battery, you need to tell it explicitly that you're still doing something. So on event, we call wait until, and wait until takes a promise, and whenever the promise fulfills, it knows it's done, and or whenever the promise resolves, it knows that it's done, and it can actually kill the service worker back down. So we'll give it a promise, and we'll give it a promise that comes from caches. So caches is a relatively new thing on the web, which is a programmatically available cache. So it's not HTTP cache or any other cache that we normally deal with on the web. This is actually a cache that you can add to and that you can get from, and that you know will be persisted. Because HTTP cache, you can't really know what's in it, and you can't know when it's cleared and stuff. But this is a cache that you handle, so you can do whatever you want with it. So caches, you call caches.open with a name. That's just a string. Let's call it bicycle app or whatever. I would suggest putting this in a variable that you can change, because it's a lot easier to clear a cache by a cache name than to clear all the entries. So whenever you want to then ship a new update to your app or something, it's good to have a dedicated name for that. But for now, we'll just do it manually like this. And this is going to give us back a promise that resolves to a cache. And the cache, we can call a method on it, which is cache.addAll. And addAll takes an array of all the files that we want to put in the cache. And we just have two files here, which is the slash, so which is gonna serve the index file for us, and then it's the js/main.js file because this is what we told Webpack to build for us. So when we do the final build, it's gonna put a file here that's called JS in a folder called JS that's called main.js, and that's actually the one that we want to cache. One last thing, and we don't really need it for now. This is just so if you're building your own service worker, you need to remember this, that if a new service worker is detected while a session is still connected to an old service worker, it's actually not going to activate the new service worker until there are no more sessions pointing to the old one. So in order to get past that, because that might not be what you want to do, after adding all of this to your cache, there's a special method on self again that's called skip waiting, which tells all existing sessions to now refer to the new service worker instead. So as I said, this is not really needed for this example, but I think it's just good practice to put it in there. So the only thing we need now, this means that when the app first launches on your screen, it's gonna make a cache version of the JavaScript file and the HTML file and put it in the cache for us. So now we need to tell the service worker that whenever the browser asks for those files, instead of asking the server, we'll just take them directly from the cache. And the way we do that is by adding an event listener that listens for a fetch event, which is when the browser, or when a browser from your domain asks for any file. So it might even be for a file that's not on your domain. But when we get the fetch event, let's take the event again. And on that event, we have a method that's called respond with. And respond with takes the value that you want to respond with as the result of fetch. And the easiest way to do this is to see if we have a match in the cache. So we'll do caches that match on the event that we that it's called with actually have a request a property on it that holds like details about what the URL is and what the port number is, and so where the request is going. So we want to see, do we have a match in the cache? The cache API though is a little bit weird because it's gonna always succeed, and then it's just gonna succeed with an undefined value if there's no hit. So this is gonna give us a cache response, and then we're gonna just use the fact that the JavaScript is a little bit untyped in itself. So if we want to just say if there is a cache response, let's just return that. And if there's not, then let's fall back to the network really and say, let's just call fetch again directly, and we'll just call that again with event.request. This means that, so this is a cache first implementation, right? So if there is a response from the cache, use that. Otherwise, just send the request on to the network and be done with it. And this is all we need for our app to run. So now, instead of actually running from our development server, I'll quit that. I'll do npm run build, and it's going to take a little longer because it actually does some nice optimizations for us, so our files are nice and small. If we open this up in a window, you should see that our dist folder here contains the index file, it has the service worker, and it has a JavaScript file, or a JS folder that has the main JavaScript file in it. The JavaScript files is 29 kilobytes, so if you run that through regular gzip or something like that, we should probably be at 8 or 10 kilobytes or something of code. So that's quite a lot of functionality and a nice little framework for us in a very little code. So let's actually go into the dist folder. We will start a dedicated server in here. Now, if we reload the page, we see that the service worker is now installed. That's the message we get for that. And that means that if we now close the development server again, so now there are no, I quit all my terminals, there are no extra servers running. I can still reload the page, and you don't even see it because it's so fast, because it's being hit directly from the cache. So now our app works offline with no internet connection. I can still connect to all my sensors, and I think that's it more or less for what I wanted to show. So hopefully we'll have some questions that we can talk about. Otherwise, that's it. So I'll stop sharing my screen for now.
Thank you so much, Filip. And feel free to flood the chat with questions.
Otherwise, Casper and I, we usually just talk for hours.
Yeah.
So just while we're on this whole cache thing, and the like just accessing sensors on the device from where you're running it.
Yes.
Is there any like extra permissions that the user may or may not have enabled in their browser that would prevent this code from running, or?
The
I don't know if that makes sense.
yes, it does. So the permission prompt is really the search for device prompt, right? It wouldn't make sense to ask for permissions and then search for devices, because we can't from JavaScript access the device before you actually chose it from the list. So that's like the security model in that it needs HTTPS to be able to run web Bluetooth, and as I said, it needs to react to a user gesture. So that's like the security model of it. As a user, you can disable Bluetooth for Chrome or for any other browser on your phone if you want to, but that would take it off from all origins, I think. I think you can block it on a per origin level as well. Like when you connect, oh, you don't see my screen anymore, but I think right next to where from the device list, you can actually say don't allow this origin to connect again or something like that.
Yeah, that's yeah, because that would be a more convenient, like for a user, if all web pages started requesting all these things, it would quickly become out of hands.
Yeah. So the point again is we can't ask for a device without a user gesture. So the user has to click on something. But of course, we could hijack a click or make the click look like a link or something. Like we could do all weird stuff. But then it would show the prompt that would show all the devices that are nearby, and we can't access them before the user actually chooses a device from the list. We can't even see what devices are available. We can't do anything. Then there's actually some new spec work.
We have a question from Abdul.
Yep, we can do that.
You want to go ahead and pose your question? You there, Abdul?
I can read it up.
Yeah,
what?
I'm here. Jesus, my bad. So as far as I could see, what you did here was caching the functionality of the Bluetooth sensors.
Yes.
But in a scenario where you have an app that needs to call to an API to get some data over the internet,
Yes.
what do you do in that scenario?
So, of course, like any other app, like if you need access to something that's online and you can't run without it, it won't work offline. So I mean that's true for Android app, or like that's true for anything, of course. If you wanted to in your service worker, you would easily write some logic where you saw me responding to everything by going to the cache, and if it's not in the cache, it actually falls back to the network. You might want to make some special rules where if your request starts with /API or something, you want to go to the network and never hit the cache, and like you can do all the rules yourself for that. And there are of course lots of helpers out there that makes that really easy and convenient for you. But the point is that we have all the power that we need to ourselves decide how we want to handle the connectivity as well. And that's kind of nice.
Ah, I see.
So yeah, and I mean, if you want your devices to report back to a service, like so you want to track somebody's heart rate or something, you would probably want to not do that at every event anyway. You would probably want to batch that up and send them off every once in a while, and then send 10 at a time or 100 at a time or something like that. And there's actually a nice API in the service worker that lets you do that. So you can actually schedule that the service worker will wake up once there's a connection again. So you can do this, and then you can batch them off in batches of 10 or 100 or something, and you can do that all while you're offline. And then the next time the computer comes online, even if the website is closed and all, the service worker is going to be woken up with an event saying, now it's time you have internet connection, and then it can read from the local database or whatever that you have on the device, and then send it off to a server. So you can actually do both.
That is smart.
There is a comment from Nils saying he doesn't have any questions at this time, but it was a really great talk and it answered a lot of questions that he had. So big thumbs up.
Nice. Thanks. Happy to hear.
What are the, not to dwell on the whole permissions thing, but if I were to save your heart rate data somewhere locally, like what is the access permissions for that? Like, could any other app come along if they could guess the key?
No. So on the
Stupid
web.
question here.
Sorry, I know you don't do web that much. So on the web, all the storage mechanisms are tied to the origin.
Okay, makes sense.
Yeah. So it has to be a request from the same domain name and host name and everything to access local storage or IndexedDB or whatever other storage mechanisms we have on the web.
Yeah, I thought so.
Yeah.
There are a couple of other great talk. Did you make some of the code available
Yes.
on GitHub or as a demo?
I'll send out the link afterwards, but if you go to GitHub and search for my name, I think there's a repository on there called Bicycle App, which is more or less this app. And
also we'll share the slides.
Yeah.
That's easy.
There's no slides, but we can share that link.
Tua says, great presentation, Filip. Lots of new knowledge. I'll have to buy some Bluetooth sensors to play around with now.
Yep. It's actually really nice because like since these are the same sensors that you use in the gym or that you use with your, classic bicycle hardware device, like these are really cheap. I think like the speed and cadence sensor, I think I bought that for like 100 krona, 150 krona or something like that. And the heart rate monitor, maybe 200 krona or something. Like it's pretty cheap to get playing with sensors today that are like professional equipment that are sweat proof and everything.
Richard says thanks.
Yep, somebody posted the link. That's perfect. Thank you, Brian.
Go star that stuff. Support your local developers.
I can show the sensors, yes. Well, I'm not gonna show you my naked belly, but I have a heart rate band around my stomach, and this is a polar sensor. All of these sensors look more or less the same. I think I have 3 or 4 of them. Be aware though that they don't all support Bluetooth, but if you get one that works with your phone, it's gonna work with this. But some of them also only support N+, which is like a fitness specific standard, which I think is technically like a subset of Bluetooth or something, but it doesn't necessarily work with that.
Life says, great talk. Would you use the same Bluetooth library in React Native, like your lit element version?
Yeah, so lit is actually not specific to Bluetooth at all. You can use lit with anything. And yeah, this is just all the Bluetooth stuff is as close to web standards as possible. So you would use that with React or whatever. I'm not sure about React Native, how that works. React Native is that JavaScript framework that actually builds real native web, native Android and iOS apps. I don't honestly know how that works.
Does anybody know? They can post it in the chat. All right, keep the questions coming. You have special access here. Ulrich says, thanks for the talk. It's interesting how it's becoming possible to access more native stuff like Bluetooth from a web context.
Yes, very much. I think so. There's a big initiative in Google that's called the Fugu project. Like Fugu is that fish that that's deadly if you do it wrong, but it's so delicious when you do it right. And the project is named that way because that's the project where they want to put as many like native features onto the web as possible. And the reason why it's called Fugu is because like it is so dangerous because of the model that like it doesn't run through an app store. People can just send you a link and it'll automatically open up. So like there's no reviews, there's no anything. So it's like the security model has to be a lot tighter on the web than it does for native apps, and that's good and bad. But it is nice. I think I'm very excited about like file system access, which has landed in Chrome. Like I think within the last 3-4 months or something like that. I think that's really nice that you can actually now grant access to a part of your file system through your browser, and so we can actually, since VS Code is actually written in JavaScript, there's actually now a VS Code version that runs in your browser and has access to all your local files, and I think that's really, really cool. More and more sensors. Go search for Fugu and Chrome, and you will find there's a huge list of stuff that they want to put in. Also, like the small stuff, like getting access to the address book, so you can look up contacts, so you can build a real text messaging app, or getting access to text messages as they come in, so you can actually build a text messaging app with the web, and lots of cool stuff. And I think actually one of the recent things to land is access to like some of the hardware authentication features that are in most phones today. Like, so you can actually access your Face ID or your Touch ID or whatever it's called. Like, so your fingerprint or your face recognition thing, you can access that in a secure way from web. So you can actually do 2-factor authentication very, very easily. I think that's really nice as well.
I think that's pretty much that's also where we ended off on your last talk.
That's always where I end up.
So, but there are more questions. So Abdul says, wait a second. Isn't file I/O from a browser a major security risk? And I think you kind of already alluded to that.
Yeah, so the point is, it works the same here as with the other thing. So we can only do it when we react to a user gesture. So the user has to click a button, and your button can then say, give access to your file system and something. And it doesn't grant you access to everything. The user can choose what folder to give access to, and for how long, and if it can only read or if it can read and write. And like the security model is pretty well thought out. Yeah, but I mean, it's no different from what your Microsoft Word or like any other application that you have has access to. Yeah, but as I see, like the difference is, and the reason why we have to do it this way, as I just said, is that like there's so much phishing going on where people would do this and then send you a link that looks like an MED or something, and you click the button and like yeah. That's why we have to think about it very carefully before we introduce powerful APIs. So the main thing to note is that all of those APIs need to be on SSL, so it needs to be on HTTPS. And that means that that's encryption of whatever is being transferred on the network all the way from the server to the client. And that means that there can't be any hacker in the middle injecting code into your code that can intercept stuff. So that's the main security concern. So once you go to a website, you can know that all the code that runs on that website comes from that origin because it's HTTPS. There's no man in the middle. And if you trust that origin to deal with your data, then we consider that kind of like an install, right? So if you trust it, then you can give access to the file or the folder, like a folder or a file that you want them to.
All right, there are a few more questions being typed up.
Nice.
Let's see. Okay, that was thanks, guys. Bye from me.
Hi, Richard.
Stage fright from Richard. Okay, Abdul, last time you talked about the fact that web is getting closer to being able to replace mobile apps. What do you think of it now? Abdul, we shall not speak of that.
Casper has a kind of a conflict of interest here. Yeah, I think the trend that we've seen in the last decade or two on desktop is going to be the same on web native platforms. So we've seen that software like Word and Excel are moving to the web. It's not even only Google with Google Docs anymore. Actually, Microsoft and with Office 365 has them on the web. And I would suspect that in a not too distant future, there might not even be a desktop version of them anymore. Because why would they write them twice and only have them available? Have one of them available everywhere and one of them only available on Windows. Like that doesn't really make sense. So I would suspect that they would do that eventually. And I would see more and more stuff like that. I would see that trend would probably go on for native as well. So eventually, more and more stuff is gonna be web. I think it makes sense. But I still think there are valid use cases for making native apps. Like it's probably gonna be a while before we can do really hard 3D applications or really complex gaming or like there are still scenarios where it makes sense to have a native app, but they're becoming less and less. Like with WebAssembly being a thing, and with the whole Fugu project, as we talked about before, I think we're getting closer to more and more apps can be replaced by web. But I think the main thing holding that back is still Apple and iOS, and iOS is still so big in Scandinavia, at least, that before we get them along, it's not gonna happen. What would be your opinion on that, Kasper?
Yeah, that's interesting. I think that's definitely moves we're also seeing with cloud becoming so affordable and powerful, like gaming, like streaming gaming on an old laptop in a browser. You can get like a decent gamer PC performance, and it's all executed somewhere else. I think we have to accept that computing as such is going to change, and also the interfaces. Like, it's not just going to be your phone. It's going to be, we're moving more towards that, both Internet of Things, but also the more ubiquitous computing scenario where you're interacting with your data and your services in kind of a mixed interface, and many crossover between the web and the native app performance. And I guess native app performance on web is also becoming, as you say, a lot more potent. So
yeah,
it's hard to see where it's going to land. Maybe it's going to be Neuralink. We all going to have a direct brain computer interface, and then there's just connected into some big cloud.
We'll see.
Then
I think it's
becomes,
nice though that we get more and more power everywhere, really, because it's not like native development has stopped. Like, it's still being better and better.
And I think there's, I mean, on Android, we're seeing a movement towards more restrictive privacy, because that's becoming a bigger concern for the private consumer, which you would, 5-10 years ago, people didn't even care what they were sharing, their location, whatever, heart rate, doesn't matter. Nobody would misuse that data, right?
Yeah.
But now it's like you have to specify very kind of at a granular level, like, I need access to this information only while the app is running, and then after that, the operating system, the framework guarantees that app is locked out.
Yeah.
And Apple is pushing more and more stuff onto the hardware, even on their native platform. So I don't know how web is going to be compared to that, because it definitely are extra levels of security that you can enforce that you won't, like for enterprise solutions, at a hospital. Imagine if you could, if you could gain control of the origin, you could, if there was a laptop with Bluetooth in an operating room, you could suddenly start communicating with all the whatever devices. So I don't know. I think there are some hardware things still that has a place. And native is a bit closer.
But I think also like a solution to this. So there's some specs going around. I think actually most of them has landed already with web Bluetooth and web serial. So you can actually get that kind of access to all sorts of weird old legacy hardware stuff. Get that access from the browser as well. But it is interesting, and it brings up some nice concerns. It is one thing to note, though. I think if there's one thing that we've been good at on the web, because we've had to, is the whole idea of progressive enhancement. Like, we know that we can't guarantee that stuff is available, so we have to code around, like, if this feature is not available, then we do that instead, and if that, and like, I think probably I would suspect that the average web developer would be more aware of that than the average native developer, because normally you take access for granted, right? Or at least up front at the install time if you get access or not.
That's a good point. All right, guys, we are nearing the at least the scheduled end of the event.
Which was 25 minutes ago.
Oh, was it?
That's nice.
Oh, well. Thank you so much. Thank you so much, Filip. This was really awesome. I always appreciate a good live coding session, and it's always impressive to see. No, I think it went really well, and when it messes up, it's usually the good. That's where you actually get into the good parts.
Yeah.
Because you gotta explain what you're doing. So thank you so much for joining us, and thanks everybody for the good questions and participating. And go check out the code on Filip's GitHub.
and come up with some topics for the future and get yourself involved. All right.
Coach
Thank
and
you, everyone.
and share.
Great.
Have a good evening.
Bye.
Thank you.
Thank you. Bye.
You too. Bye.